Now we are going to start with the group 16. So as you all know that you must be familiar that the group 16 is being given a common term, that is chalcogens. You know that what do we mean by chalcogens? It means ore forming. They are actually ore forming. So that is why they are called as chalcogens. So what are the members of group 16? It is oxygen, sulfur, selenium, tellurium and polonium. Now as far as symbols are concerned, then oxygen is denoted by O, sulfur as S, selenium as Se, tellurium as Te and polonium as Po. Now starting with the first property, that is the electronic configuration. So we know that the oxygen atomic number is 8, so its configuration is helium 2, 2s2, 2p4. So if you talk about the general electronic configuration, it is obviously ns2, np4 because they have 6 electrons in the outermost shell. Sulfur is 16, so it is neon 10, 3s2, 3p4. Selenium is 34, argon 18, 4s2, 4p4. 3d is filled, already filled, because after the filling of 3d only we fill 4s, right. Tellurium is 52, krypton 36, then DNF filled, 5s2, 5p4, polonium 84, xenon 54, 6s2, 6p4. So this is how you are going to write the electronic configuration. So now we are going to start with the physical properties of this group. So our first property is atomic and ionic radii. We know that atomic and ionic radii means the distance of a valence electron from the nucleus, or you can say distance from the nucleus to the valence shell is called as atomic radii. And when an atom turns into an ion, that means it lose or gain electrons, then its radii is called as ionic radii. Depending upon that, whether it has lost electron, then it is cationic radii, and if it has gained electron, it is anionic radii. And as you all know that cationic radii is always smaller than atomic radii, and anionic radii is always bigger than the atomic radii, because it has formed actually after gaining electrons, so repulsion increase, and cation actually formed by losing electrons, so nuclear charge increase, so therefore size shrink. But the variation is same as we will do for the atomic one, it will be same for the ionic ones. But you have to keep in mind that the cations are always smaller than the parent atom and anions are always bigger than the parent atom. So look at the first property, atomic and ionic radii. So if we compare the first thing what we will do is we will compare with the previous group. So if we compare with 15th group, that means nitrogen family, we compare this group 16 with 15, what we see is that here we have oxygen, here the configuration is 1s2, 2s2, 2p3, and here the configuration is 1s2, 2s2, 2p4. So that means the shell remains the same, it remains 2p, but now one electron is added to the 2p. That means if we compare the electronic configuration, an electron is added to the same shell. And as we know, when electron is added to the same shell, that means there will be 3 factors, because if an electron is added, obviously the same number of protons also add up. So that means nuclear charge increases, and also because the electron is added, so therefore repulsions are also quite higher if we compare it with the 15 group. And but if we compare the strength of both things, the repulsions and the nuclear charge, we will see that nuclear charge is more pronounced, therefore the size actually decrease. So if we compare group 15 and group 16 is going to be smaller, and what is the reason behind? Due to increased nuclear charge, right. But if we talk about the like if we move along the group, if we move in a 16 group, then what kind of variation we see? Like if I move from oxygen to sulfur to selenium, we see that as you can see here, it is the last shell is 2, here the last shell is 3, 4, 5. So every time a new shell is being added, every time a new shell is being added, or I'll write it, the new shell get plus every time. So when new shell get plus, what do we see? We see that electrons will also increase and equal number of protons will also increase. That means the nuclear charge is also increasing, and along with that there is an increase in the shielding effect also. we know that shielding effect is that that means filling of inner shell electrons. They will somehow try to reduce the effect of nucleus towards the last shell, and as a result the last shell will experience an effective nuclear charge, and that is always less than the actual nuclear charge. So that is why the size increase. So what we see as we move down, new shell is always added. So because obviously new shell is added, so that means the electrons are also increasing and equal number of protons are also increasing. So nuclear charge increases, and along with that, because due to filling of inner shell electron also take place, shielding effect is also increasing. But if we compare the strength of two, we see that shielding effect is more pronounced. So that means the last shell somehow expand due to filling of the inner shell, because the last shell is experiencing the effective nuclear charge, which is always less than the actual nuclear charge due to filling of the inner shell electron. So as we move down, the new shell is added, so due to which the nuclear charge is also increasing, and the third shielding effect is also increasing. But as the shielding effect is more pronounced, so we say that size increased down the group. So this is what is the atomic and ionic criteria. I think it's clear. So if we compare with 15th group, it is smaller due to increased nuclear charge, but if we compare within the group 16 group, the size increase because there is increase in the nuclear charge as well as shielding effect, but shielding effect is more pronounced, right? So this leads to the expansion of the electron cloud. Coming to the second property, that is the ionization energy. We know that ionization energy, suppose I have nucleus and I have electron in valence shell. I need to remove this electron, then I have to supply it with some energy, and that is called as ionization energy. So if I compare the ionization energy of 16th group with 15th group, we know that here the configuration is Ns2Np3 and here it is Np4. By looking at the configuration, you can easily make out that obviously, because they are smaller actually, if we compare their size, they are small, but if we compare their ionization energy 1 of 15th group is more than the 16th group. As you can see in the configuration, they have 3 electrons in p orbital, that means it is half filled, and we know that half filled and fully filled orbitals are more stable. They actually have a configuration similar to the noble gas configuration, and we just believe that they are more stable. So that is why in order to disturb this stability, we need to supply obviously with higher energy. So group 15 will have high energy, although it is bigger than 16, but still its ionization energy will be higher. The reason being because its configuration Ns2Np3, p orbital is half filled and half filled orbitals are more stable. So that means 15 group is going to possess the high ionization energy, though it is big, but still it has high ionization energy. Now if we compare the ionization energy of the 16th group, that means if we move along the period from oxygen to polonium, what we see that as we know, as we move down, ionization energy always decrease. The reason being it depends upon the size, and size further depends upon the nuclear charge, right, and the shielding effect also. We see that as we move down, there is increase in a size because there is increase in a shielding effect. So there is increase in a size. So that means the nuclear charge is somewhat smaller than the shielding effect. So that means the outer electron are not experiencing that much force. So that means the energy which you need to supply from outside in order to remove the electron will be comparatively less. So we will see that as we move down, the size in we know that nuclear charge is also increasing, shielding effect is also increasing, but if we compare the strength of 2, the shielding effect is more pronounced. So we will say that nuclear charge is decreasing, that means the valence electron is experiencing less force of attraction, and less force of attraction means that the ionization energy will decrease. So that means along group ionization energy is decreasing. I think it's clear. Now we'll move on to the third property, that is the electron gain enthalpy. Now as you can see here, like if we talk about 15th and 16th group, they have configuration Ns2Np3 and they have Ns2Np4. As they are smaller in size, first of all, I will make you familiar with electron gain enthalpy, as you all know, but still we'll recall. Electron gain enthalpy is the energy released when we add electron to the outermost shell of an atom. Here we were taking out the electron, and here what I am doing is I am going to add up electron, and when we add an electron, there is always release of energy, and that energy is called as electron gain enthalpy. And you know that more is the attraction for the incoming electron and more is the energy release because there will be more stability. So now if we apply this thing in 15th and 16th group, we see that this is bigger in size, right, and moreover it has a stable configuration as compared to it. So that means it doesn't want that electron to be added in its electron to be added in its valence shell. So its electron gain enthalpy will be you can say will be less negative, negative. That means it does not have attraction for the upcoming electrons because it is already half filled, and we know that half filled are almost stable. But if we talk of 16th group, they are actually smaller in size, and moreover they are more nearer to the noble gas configuration. Like if they will receive an electron, their configuration, like they have 6 electrons at present, if they will gain electron, their configuration will change into 7, and then they will gain one more and it will change to 8. So that means they are more nearer to the noble gas configuration. So that means, and because of smaller size also, they will have high electron gain enthalpy. They will have attraction for the upcoming electron, and due to which the energy release will also be more negative. So we say that the electron gain enthalpy is more negative for the 16th group. Now if we talk of 16th group, if we move along the period of 16th group, what we see that as we know that the size is increasing, due to which the electron gain enthalpy is becoming less negative. It is becoming less negative. See, whenever you are talking about electron gain enthalpy, never use this term that it increase or decrease, because here the energy is released. So whether we either we say that it is more negative one is used where the attraction is more, or you can say it is less negative. That means the attraction is there, but still the attraction is little. And if you say that electron gain enthalpy is positive, that means means you need to supply energy. If you need to add an electron, there will be no energy release, because it does not have any attraction for the upcoming electron, right. So try to use these kind of terms, more negative, less negative and more positive, when you are talking about electron gain enthalpy. Never use increase or decrease, right, because it will make a difference whenever, like there will be a different term when you say it increase, it means something else in the positive and negative term, and if you say it will decrease, then also it make a different sense. So try to use that it is more negative, it is less negative or more positive, right. So here as we move down, the size is increasing and nuclear charge is decreasing. So therefore the attraction for the upcoming electron is less, because nuclear charge is somehow less. So due to which electron gain enthalpy becomes less negative as we move down. But if we compare the electronegativity of oxygen and sulfur, that is these two members. So as we have seen that oxygen is smallest of all, like in this group, which is smaller, oxygen is smallest. So we know that smaller is the element, more is the attraction for the upcoming electron due to increased nuclear charge. But here we see an exception, that in case of oxygen, the electron gain enthalpy is comparatively less negative as compared to the sulfur, it is more negative. The reason being, oxygen is too small in size. So when an electron will approach towards oxygen or will add that, it will suffer maximum repulsions, and due to which oxygen won't be in a need to take that electron, because repulsions will somehow increase to a good extent, you can say. So in order to avoid that repulsion, its electron gain enthalpy is less negative as compared to sulfur. But in case of sulfur, when an electron is added, it has an affinity and there is no such repulsions. There are not so much, or you can say the repulsions do not occur to much extent. It can actually take up an electron. So therefore sulfur will have more affinity for the coming electron and oxygen will have the less affinity. The reason being because it is smaller in size, the incoming electron will suffer maximum repulsions from its own electrons. So this is how you are going to explain the electron gain enthalpy. The next property, we are moving on to electronegativity. What is electronegativity? It is the tendency of an atom to attract shared pair of electron towards itself. That means suppose I have A and B and this is my shared pair. If their electronegativity is same, this bond pair is going to remain in the middle. But if they are different, there exists a difference in the electronegativity, then shared pair will move towards the atom which is more electronegative. Like in this case, I took B as more electronegative. So shared pair, earlier it was in middle, but because B is more electronegative, it gets displaced towards the B. So electronegativity depends upon the size. It depends upon the size, and size obviously depend upon the nuclear charge. Means if an atom is smaller in size, it is going to possess high nuclear charge and it will be highly electronegative. So if we compare 15th and 16th group, this is smaller in size. it is smaller in size. So obviously electronegativity will be more. But as we move down the group, along the group in the 16 group actually, from oxygen to polonium, what we see, there is increase in size and there is decrease in the nuclear charge. So therefore electronegativity decrease as the size increase from top to bottom. So this is how you are going to answer the electronegativity. Now the next property is melting and boiling point. So if we compare 15th and 16th group, obviously they are of small size and therefore their melting and boiling point is comparatively high because due to high interatomic interactions. But as we move down, we see that melting and boiling point increase because we know that in melting and boiling point there exists in van der Waals force, and van der Waals force just increase with increase in the molecular mass, atomic mass you can say. So as we are moving down, we see that there is an increase in the atomic mass, there is increase in the van der Waals force because more is the area, more is the van der Waals force, and due to which the melting and boiling point is gradually increasing as we move down. The next is oxidation state. As we know, they have configuration Ns2Np4, so that means they are very near to the noble gas configuration. They will need 2 electrons and their oxidation state will be -2. So mostly the oxidation state exhibited by these members is -2 because they have Np4, so they are in immediate need of 2 electrons in order to acquire noble gas configuration. But we see that, like if you talk of oxygen exceptionally show one more kind of oxidation state with fluorine. Like we have compounds O2F2 and OF2. In O2F2 it shows an oxidation state of +1 and OF2 it shows an oxidation state of +2. It is an exceptional case when oxygen combines with fluorine. Otherwise the rest of the members can also show positive or negative states depending upon their electronegativity. And you know that except oxygen, all other, the sulfur, selenium, thorium, polonium, they can also show 4 and 6 oxidation state also. The reason being they have vacant d orbital. So if they need to bond with some other atoms, so they can actually, the excitations can actually take place because they have d orbital. You know that 3 subshell has, the third shell has 3d orbital and 4 further has 4d, 5 also have and 6 also have that. But oxygen has 2s2, 2p4 and we know that 2d is not possible. So that means oxygen do not have d orbital, so that kind of excitations are not possible. So due to this we say that the rest of the members can show 4 to 6 oxidation state because excitation is possible and can accommodate more atoms, like it can bond with more number of atoms as it has vacant d orbital. So this is what about the oxidation state, but mostly the oxidation state shown is -2. The next property is catenation. You know that catenation is linking with its own kind of atom and giving rise to long chain. This is what is the catenation. So we see here in this case oxygen exhibit catenation but up to very less extent. Like in peroxide you can see that 2 oxygens are there, means it shows but up to very less extent. But if we compare with sulfur, it shows to a good extent because see, for a catenation to occur there should be a strong bonding between, single bond should be strong between OO or SS or any other atom we are talking about. But here you know that oxygen is smaller in size. So when the 2 oxygen will approach each other, there will be repulsions between the non-bonded electron pairs, and this is why they will not try to come together and they will not get bonded with the single bond, and somehow if the bond is formed it is not stable actually. So that is the reason that it shows catenation up to less extent. The next property is allotrophy. We know that allotrophy is the existence of element into 2 or more forms and those forms have same chemical properties but different physical properties. We see that these group also actually possess the allotropes, like in case of oxygen it is O3, ozone and O2. In case of sulfur, sulfur has 4 allotropes: rhombic, monoclinic, plastic and colloidal. These are 4 allotropes. And further we have selenium. Selenium has 2 forms, red and grey. Red is amorphous and grey is crystalline. Further we have tellurium. Tellurium exists in metallic and non-metallic allotropes form, and polonium exists in alpha and beta forms. So these are actually the allotropes. So as you can see, they actually show good forms, good allotropic forms. So they all actually exhibit the phenomena of allotropism. Last is the state of existence. So if we talk about oxygen, we know that oxygen exists in this form. It is a diatomic gas, O2, and 2, 4, 5, 6, 7, 8, these electrons are like that. So as you can see, it doesn't have any unpaired electrons, so we say it is diamagnetic. But experimentally by molecular orbital theory, it has been proved that it is paramagnetic. But still, if you will draw the structure like this, you will obviously find out that there is no unpaired electron, so it is diamagnetic. And if you talk about sulfur, sulfur exists as S8. It has a special structure like this, which is called as puckered ring like structure. So it is all 8 sulfur like at this position. This is a crown kind of structure or a puckered ring like structure. And you know that tellurium, selenium also exist as 8 members, means 8 atoms together, or you can say their atomicities, they are octa-atomic, or they are categorized as polyatomic. So this is what is the state of existence, and I think you are familiar with the physical properties of this group now. So if somebody asks you about in comparison to group 14 or how it varies along the group, I think you should be quick with an answer. Don't forget to I'll just focus on the important points. Here if we compare 15 and 16, ionization energy is an important factor, as 15 group has lower ionization energy. And if you compare oxygen and sulfur electron gain enthalpy, we see that oxygen it is smaller, so it should have more negative, but actually it is less negative because of repulsions. And likewise we saw electronegativity is the simple, you know that. And along group what we see, melting point increase because the atomic mass is increasing. Oxidation state, this is an exception. In O2, F2 and OF2 it is showing a different kind of thing, and oxygen cannot show this 4,6 oxidation state because non-availability of vacant d orbital. Likewise, if we talk about this structure, this is important, as sulfur exists as octa-atomic, that is the great number. And what is the structure? It is a crown or a puckered ring like structure. And moreover, this group is showing a beautiful allotropic forms. So you need to remember all these forms: monoclinic, plastic, colloidal for sulfur, red and grey for selenium. Likewise, you should be well versed with the allotropy as well. So these are the physical properties of the group 16.